All right, I think we'll go ahead and get started. And the timing on this may be a little bit complicated because I added a piece to the end. I did what no speaker should do, which is suddenly add material and not necessarily compensate for it. Because of a few pieces I'd like to be able to talk to you about and mainly hear back from you about in the Apache Mahout project. And these are changes that are happening, well, as we speak, and certainly last week. So I just add a little bit on at the end. So I need the help. I'm going to turn on a little watch here, but I need the help of somebody who can pay attention to time, and that's generally not me. So do I have a volunteer from the audience who can wave a flag when we're 30 minutes into this? That would be 3:15. Super. All right, here's a book as a thank you reward. And if you would just give me a signal at 3:15, I'd appreciate it. Okay, my name is Ellen Friedman. I am going to talk to you about what I'm calling practical machine learning, meaning some changes in the approaches of the way that people are doing machine learning as it goes into very much mainstream and businesses right now. It's being picked up and used in a lot of places that it hadn't previously been done, and that requires some changes in the approach. And as an example today, to talk to you about some changes, some innovations in the way recommendation can be done so that it can be done in a very simple and very easy fashion. I'm also going to spend a little time at the end talking to you about the Apache Mahout project, hopefully. The alternative name to the talk is I Want a Pony, which is actually based on this little publication, and you'll see why in a minute. So, as a short reminder to myself, I'm going to talk to you briefly about a new language. As I mentioned, a simple recommender, and also about the Apache Mahout community and the code. So the question is, what does machine learning look like? And frankly, to a room full of very technical people like yourself, you probably glance at this and it just looks like candy. But to most people, and myself included, we have a very different reaction to that sort of thing. It's strange, it's off-putting, it's what those other people do, and that tends to keep it isolated. So what do you do about that? What should you do about it? And why does it matter that this is not an inviting thing to most people? Well, one way to look at it is in the bad old days, the people who are doing machine learning, the data science team, tended to be hidden away in some fine academic institution, maybe the R&D lab of a big business, or possibly stuck in a hut in the backyard, carefully isolated from other people, where the brilliant people are staying up all night coming up with great ideas, but isolated. That's changed now. Data scientists and machine learning teams are being integrated into businesses in a very big way. There's huge opportunity in that right now. And what that means is that the people who are on those data science teams need to be able to interact in an effective way with other teams within the business. Perhaps with people who are setting the business goals, who know the business goals, and who, by the way, tend to be the ones who write the checks and to do the hiring. Also with people who have content or domain knowledge that's essential for the projects. So it's very important that they be able to speak effectively to each other. And let's face it, it's not very practical to imagine that these other people are going to come up to speed on the kinds of programming and mathematics that the people who are practitioners are able to do. It's just too hard. And so what's important is to be able to find some sort of common language where people can understand what's needed from the two parts of the team and work together effectively. And that's what I meant by a new language. So really what I'm talking to you about is how those of you who have the technical skills can develop ways to talk effectively to the non-coder. As we mentioned, it's important for getting domain knowledge from experts, but it goes the other way as well. When somebody is asking you to do a machine learning project, they're putting expectations on you, and those expectations are based on practical business goals, and they have to meet in an engineering way. They have to be a reasonable trade-off between resources, goals, timeline, human resources. Are people being hired? Who's being asked to do what? What is your hardware? What's happening in the business? A huge number of different trade-offs and questions about the architectural design of the projects themselves. So even the people who are experts in knowing how to do machine learning are now faced with a new challenge that they have to understand the business side of things. They have to shift it into a practical mode. They have to let people know what are reasonable expectations, and they have to do a good job themselves of understanding what the real goals of the business are. So that's part of what we'll be talking about today. And I added a couple of bullet points here. I just noticed during the conference so far, a couple of other people have referred to this kind of shift where suddenly people are needing a new set of skills or a new set of communication within a company. Matt was talking about Internet of Things, the deluge of data that's now coming in from data sensors, in some cases turning companies who hadn't previously been dealing with these kinds of large data set analysis or machine learning problems suddenly need that kind of expertise. They either need to hire it into their company, train up people, or hire services, but they need to be able to understand what's going on. Brian had a good quote this morning. He said, even when you're building the language itself, it's not so much building the code or doing the coding, but the real hard work comes in the stewardship, in those interactions with people and within a community. And so whether it's dealing with a community like an open source community, such as the Apache Mahout project, or dealing with communities that are within the business itself or between a business and a machine learning service, these are really important things, and they can make or basically break a project's success. Joel also talked about the importance of the way things are said when he was talking about Stack Overflow, the use of rules, and there were some problems. This was the keynote yesterday, and he basically said that without changing the rules, they changed the way the rules were described. They picked a language that worked better for people to have an understanding of what was being expected and why, and the result was that they ended up with a much better result in terms of the questions being offered. So how are you going to go about doing this? Well, this is going to be a part that I'm just going to skip through real fast to make some time at the end. But basically, there are different ways to talk about things in simple fashion. I was doing a training exercise for a group of sales engineers and got ready to do this machine learning piece. And they said, oh, have you dumbed this down for us? Well, first of all, that'd be hilarious coming from me. I'm a biochemist, a research biochemist. I'm not a coder. I'm not a machine learning expert myself, though I'm learning a lot about it. So no, I wouldn't have done that. But I would never use a term like that. I said, no, I haven't dumbed it down. I've clevered it down. I think it's really important to be able to get to the heart of what matters, to think about things conceptually. This really matters to be able to communicate with people who don't have the language of mathematics or computer code, but because they can actually understand the ideas, and that's what matters. You can see if your ideas and expectations are aligned, even if they don't have the tools to carry it out. But it also has a payoff for you, because by stopping and thinking about the fundamental ideas, you'd be surprised how much a difference it can make in your own planning, in your own execution of a project. So I look for different ways to communicate fairly complicated systems in really simple ways. This is a little exercise that we do sometime. We don't have time to go through all of it, but what do you see here? People come up with different things. If I kind of do some mental priming by mentioning maybe animals or species of animals, you start to see pairs here. You say maybe there's a pair of horses, there's a pair of hippopotami. Depending on the systems you work in, you might say it looks like two different Hadoop distributions up there. You'll see what you're looking for. If I just say, what should you find here? That's a different kind of question. So instead of doing something similar to classification, which is what we were just doing, you have to discover the categories. And so you might take an approach like clustering, where instead of 9 squares, if this was millions of data points, you don't know exactly what categories you should look for. You can do some sort of a clustering exercise, use some of the very excellent clustering algorithms, discover meaningful patterns, then have human insight to decide if those patterns make sense in terms of, of the kind of categories you want to look for, and then set up a machine learning model, possibly using classification, where you use the categories you discovered through clustering as basically your target variables for a classification problem. So these complicated problems, it doesn't mean a person then knows how to do it, but at least they get the idea of what it is that you're trying to do, and you can maybe meet on common ground in terms of the goals. So we'll just move on here. We talked about this already a little bit of why it's important to take these changes in terms of how you think about a project and how you communicate it to other people. But I just want to call out 2 things here. The let the data talk is a reminder to me to tell you a quick story. When I was a research biochemist. I was in graduate school, got ready to publish my first scientific paper. I was doing actual, wet lab biochemistry. I'd made my little discovery. I was about to publish it in a refereed journal. My mentor told me, okay, before you sit down and actually start organizing and writing the paper, he said, set aside what it is you think that you've asked and set aside what it is you think you've answered. Do a mock-up of all of the figures that you think might be in the paper, because those are the data. That's the real world, as close as we can come to it. That's the real world, and just spread it out on your desk and let it speak to you. Stop and look at it and ask yourself what it tells you. And it might not tell you anything other than what you already thought it was talking about. It might tell you something very different. So I did that, and the first thing I noticed is that the question I'd asked was a good one, and the good news was that the data I had supported the answer I thought I had come to. I was all good. I could write my paper. But I sat there and thought about it for another minute or two, and I realized that I had the beginnings of an answer to a phenomenally larger and deeper question, one that actually, to some extent, changed at the state of the art at the time, changed the field I was in, which was trying to define on a physical biochemical basis at a molecular level the actual switches that turn on and off genes. So this was, of course, about 350 years ago when that was new knowledge. And I realized that the system, this was a bacterial control system, that the system actually worked in a fundamentally different way than people had thought, and that I had the beginnings of a way to do experiments to get that information. Completely changed the direction of my dissertation. I discovered some very interesting things. So the field that you work in is a very different field, but I think that the principle is there as well. You give yourself a moment to step back, look at the basic concepts, not only let you organize your thoughts better in terms of your project or communicating to other people, but it frees your mind of all the little tiny details that you have to track while you're actually doing a project, and it gives you that little tiny window of time to be creative, to come up with innovations, and you may find that some of your best ideas come in that moment. So giving yourself a chance to look at the fundamental ideas when you start a project can be very valuable for you as well. And we're going to talk about several questions in the kind of think before you leap, and let's just leap into the questions. So one question is, when you start a machine learning project, how good is good? And that's one where understanding the problem, understanding the business situation, if it's a business application, and in some human insight is very important. This isn't the sort of thing where you build a system, you do a test, you get a report card, and it's good, bad, and you're done. It's a system where you have to understand what is practical, what does success look like, what should you be measuring, and how far along the ladder or the ruler of success makes sense given the time and the constraints that you have in your project. So I would say how good is good enough? It sounds like we're always looking for something that's not successful. But what we really mean is, have you hit the right place? And maybe you don't want to spend a lot of additional time in refining something and getting some infinitesimal improvement. This is a quick reminder. This is actually a longer piece of a talk, but I'm going to skip through it, having to do with classification. But as you build a classification model, you have a first step, which is basically to take training data. You hold out some of that data for evaluation, build your model, train the model, evaluate it against the held out data. And so you come up with your first level of evaluation. You have to decide, was it good enough? Almost invariably it won't be. You go back and tweak some knobs, do some tuning, maybe adjust the data, the features that you've extracted for your classification. You try it again, you keep trying it again until you feel it's good enough, and you go ahead and copy and deploy it, but you don't stop at that point. You have to go on evaluating because in the first place, you want to make sure that your model, that your code has not begun to degrade, but more importantly, or probably more likely, you have to keep evaluating to determine whether the world has changed. Is the thing that you're doing, it may be still doing its job perfectly, but if the outside world has changed, it may not be effective anymore, and that gets back to understanding the practical external goals. So how good is a really important question to ask. Another question is, are you asking the right question? And am I going fast enough? No, I'm not, so I'm going to speed up here. Quick story here. This is a true story about, 5 years ago. This is a company in San Francisco that, I don't know what they do now, I think they do the same thing, but at that time, an online business that was trying to do targeted offerings of various items to buy for people, for their customers, and what they were trying to target is to match items to people's personal tastes. That's not unusual. This business was based on trying to provide items that were on sale, that were heavily discounted. So shoppers who want to go out and shop for a sale could do that and find the right items. And so they hired as a person to help them build a machine learning system for that. I know about this because it happens to be the co-author of this little pony book here, which is why I heard the story. And we used it as an example also when we wrote a book called Mahout in Action, which is an actual book-sized book done by Manning and talking about the Apache Mahout project. So what happened in the story is they built, it was actually turned out to be a fairly difficult problem that can't go into the details of how it was built, but they built a recommender, they did evaluation, they evaluated against training data. It just worked beautifully well. They deployed it and tested again, and it was still really making appropriate recommendations. It's a combination of classification and recommendation, but it was offering the right items to the right class of people. It was just working great. So it's good, they're done. They deploy it and then wait for that big pop in business, which is why the business had taken the choice to do this targeted project. And it didn't help. So it was a beautifully functioning machine learning project that totally didn't meet the business goals. So after a lot of hair pulling and worrying about what was going internally, missing something, is it the data, is it the code, what's going wrong, but you keep testing it, you have to believe the data, it was working properly. They figured out is that they had actually asked the wrong question. So the way I can explain this is if you've ever gone to a sale, big department store, maybe an outdoor store that sells gear, and they have their big annual everything slash prices, and a huge number of people all rush in, and in the first 4 or 5 hours, they clean out everything that anybody might ever want to buy. And you come in hour number 6, and somebody very cleverly directs you to the aisle that has the type of item that you're interested in. So that recommendation, you've been aligned with what you're looking for, and you go there. So the recommendation model worked, but what you have are the leftovers of a bunch of junk that you wouldn't want to buy no matter what was recommended. And so they weren't getting the pop in the business. And they realized it was as simple as the fact that the point at which they were collecting the input data about what items were on sale didn't have a time restriction on it. They had to find those items within a certain amount of time. They had to have a very fast responsive system, which they did. But they had to put in a time restriction so that they could get to the items very fast after they went on sale. They made that change and boom, pop, the business worked great, wonderful example. So it's a good reminder that it really does matter to ask the right question in a practical sense because this is practical machine learning. But I still want a pony, so let's move toward that topic. This is a reminder to tell you that the Apache Mahout project that we're going to talk about at the end is a large-scale, it's an Apache project, it's open source, it's an open community, it's a community-developed project, and it is actually used in production. It works really well. It's not easy to use. It's definitely not a pop it out of the box and use it. That's about to change. The Apache Mahout project is changing fundamentally, and that had started about 6 weeks ago, and that's part of why I'm changing some of the things I'll talk about at the end of the talk. But it has been used and has been used in production for a long time. This was a Wired article from about 1.5 years ago. Overstock.com made millions of dollars making a recommender using this pure Apache Mahout project. Are you using the right data is a good question for any machine learning project. So let's dive into our simple example here. What are we doing on time? Okay, so if you have, in order to make recommendations, you think, how do you figure out what a person's preferences are? How do you figure out where everybody's preferences are? What are their tastes? What should you offer to them? How do you look at the items? Do you look at the characteristics of the items? So what do you look for? Do you look for the characteristics of the items? You're wearing a red shirt, beautiful red shirt. So would you assume that you love the color red, so you have a red, we should offer you a red car, red food, and red everything. How do you do this? Or do we look for what you as an individual rate? You go on some site, you check 4 stars, you check 1 star. That kind of rating is something that people have commonly used for recommender systems, and it is almost universally a bad choice. People don't actually know what they really like or not. They don't know why they do what they do. But also, it's a very skewed example. Not everybody takes times to do those ratings. Sometimes they only do it because they were so upset about an item, or they did it because they were so upset about something that had nothing to do with the item that they're rating, or they loved the item they're rating, or they were eating good food while they watched the movie, and so they say it's a great movie. They're not a good source for really understanding what people's preferences are. But the good news is, since the internet happened, and we have millions and millions and millions of people who are out there doing your work for you, so they're out there conducting experiments nonstop to find out what people's tastes are. And instead of looking at what people say, and I now have to correct this, I don't mean don't do sentiment analysis on a social site like Twitter or Facebook. That's a very different kind of thing. But I mean, don't look at what people say they like, as in they're doing ratings or so forth, and instead actually look at what they do. If you watch the behavior of a huge number of people relative to some event or item, you begin to understand or to be able to predict what you or you or you will do relative to that item because of the connections of other people. So they're doing the test for you. That is a very good source of data for this kind of recommender. So in the simplest possible way, I tried to figure out a way that these talks could be done without using any math, so that anybody could look at it and enjoy it, and I decided it was basically a dog and pony show, so here we go with the dog and pony. All right, so it's a silly toy example, but it'll set the idea and show you how you could set this idea for somebody else. If we know that Alice got an apple and a puppy, and because of the because of the keynote yesterday, I have to say that the puppy was named Taco, so we have more external references, so he can get into Wikipedia eventually. All right? So we'll be sure and document this, as you've seen it in print now. All right. And we know that Charles got a bicycle, and now we've got Bob, and Bob has an apple. And so what we're challenged to do in our machine learning program here is to decide what else would Bob like? What do you want to recommend for Bob? So you think through this, and you say, you know, we know he got an apple. We know Alice got an apple and a puppy, and so he needs a puppy. I mean, it won't be named Taco, but still, it'll be a puppy. So that's a good choice as a recommendation. You get the basic idea of how recommendation works when you use the behavior of a crowd, the interaction of a user, a human, and an item, some action toward an event. So you have an association between a human and an event, and it tells you something. Now, we're not looking at this as just what are the most common items that everybody liked, or who does the most watching of movies or whatever. It has to be the individual association of a person with individual items or individual actions. You're really looking at a huge group of those individual actions, and those become the input data for your recommender. So you get the idea of how it works, but by the way, Bob, like me, also would like a pony. And so let's look at what happens when we consider that these people all want a pony, because everybody wants a pony. We have a new user here. We want to make a recommendation to Amelia. And all we know about Amelia is that, like everybody else, she likes or has a pony. So what would you recommend for her? Well, if she didn't already have a pony, you'd offer her one, because everybody seems to like a pony, but that's not very sophisticated. You don't need machine learning for that. And in fact, you don't know what else to offer. That your data don't do you any good, because all you know about her is this ubiquitous item. It really doesn't help you very much in terms of building a recommender. So very popular items that co-occur with almost everything, in fact, are not very useful, except for very special situations where you're trying to recommend something like razor blades that you know people want to buy over and over, but that's a different kind of situation. What you're actually looking for is what's called anomalous co-occurrence, or the source of the interesting co-reaction between people and things. I'm going to explain this as we go through it, but I'll basically show you that our recommender, which is built with Apache Mahout, relies on building a series of basically three matrices. Excuse me, I come from a different background, three matrices. And the first one is a history matrix, which is looking at the user history of each user and the items that they interact with. We transform that to a co-occurrence matrix, which is an item-by-item matrix in the choice that we made. And we look for the interesting or anomalous co-occurrence. That's where we pull in row similarity job from Apache Mahout, and we use that to build what we named an indicator matrix. You find some data, some way to identify what are the items that should be recommended. So using our toy example, you can think of the log files as being the association between each user and each of the items that they've interacted with, but obviously more normally you might see it represented in a different way. You set up that first matrix, the user by item matrix. convert that to an item or transform it to an item-by-item matrix, and you want to be able to tell where the co-occurrence is useful. You use the least log likelihood ratio for that. You end up with this indicator matrix, and in, again, our toy example, we can see that the apple and puppy are an interesting association. Pony falls out because it was associated with everything. Here's a point where I'll remind you of another idea. It is not necessarily true that simple is always better, but it very often is better, and it's worth taking a look. And I noticed that same thought got presented this morning, so I added this: simplicity matters, and more importantly, when something is unpleasant, people avoid doing it. So finding a way to build a recommender and deploy it and have people use it and maintain it really matters, to do that in a way that's not so unpleasant to do, especially for companies that don't already have an inherent data science team. So the innovation that we talked about in this little publication is becoming very widespread now, and it's the idea of exploiting search technology to deploy the recommender. So once you've gotten to the state that we're at here, you know what data, you know how to find anomalous or interesting co-occurrence, how are you actually going to deploy that recommender, interact with new users, and give them a reasonable response, a reasonable recommendation in real time without adding a ton of extra work for things that you have to build? And the answer is use various forms of search technology. So what happens is, and in an example I'll show you, we use Solr, and we happen to use a version of Solr that had an enterprise version where it's wrapped around with what's called LucidWorks, but it doesn't really matter. You could do this with Elasticsearch or whatever search technology you like. So using Solr, you basically have a series of documents. There's a document for each item that you might be ever willing to or planning to recommend. You first take the item metadata and you store that in a collection of Solr documents. And I emphasize here, you're storing that just so you can identify which items you're recommending, but you're not using the metadata of the items. You're not using the characteristics of the items to form the decision about what should be recommended. We're not saying that because this gentleman has a red shirt, we look at the characteristics of his red shirt and decide what to recommend. Instead, we just watch what he does, but we have to have some way to identify the items. So that's the first step. This is an example of a Solr document. Using our example, this is a document for puppy. You have a way to have an ID, a way to identify it, a little description, Swedish little puppy ever. It should have said taco, of course, here, but I didn't update my slide. And so you're set up now with the first half of what you're doing with search. Now you go back to the output of your machine learning, your Mahout model, where you have identified these indicators of significant co-occurrence. You're basically taking that line out of the indicator matrix and just adding it as a new field in the Solr document. You don't even have to set up a separate document. You just add a field, it's called indicators, and now you have a searchable index document. Very, very easy way to deploy your recommender. We built a little recommender out of this system as part of a machine learning course that I wrote. And the company Music Machine doesn't exist, but we built the website was real, the recommender was real, the data, we used an open source data for music listening, and it wasn't adequate for what we were doing, so actually we, being the people I worked with, certainly not me, devised a way to do a synthetic data generator from that, so it mimics real behaviors. The recommender actually works. It doesn't give you the stellar kind of recommendations that we do if you have a fantastically large number of real interactions, because in fact it does actually matter what the data are, and these are synthetic data, but it proves how the system works. So we'll take this and just do a real quick run through, if there's still time, and there is. Okay, so you go on the Music Machine site, thank you. So you go on the Music Machine site, you as the user now take off your developer data scientist hat and become the general public. And this is a site, it's a listening service, and you can pick items by an album, a track, or by an artist. And so it records the listening history. So that's the user interacting with an item. The item could be a particular artist. It could have been chosen by an album. It could be chosen by a track. We actually had Solr collection for each of those, and there's a single document for each item in that collection. In this case, the person listened to this Take the A Train, which means they're either really interested in classic jazz, or it means that they're about 92 years old. And this was their musical taste, but this is the one that popped out. Okay? And we go back to the log files, the data, the input data here. Just a quick look. What you have here is first an indication of the time, just the running time in the system, so you can tell how long somebody listened. Beacon, in that column, you can tell if they started listening to the music, how long they listened. I think this beacon is every 10 seconds, yes. And then you see some of them make it to a finish. Look at the top line there. There's a song that they started, they got through about 10 seconds and decided they didn't like it and stopped, or they liked it so much they didn't want to listen to it again. Which is, seriously, which happens. That's one of the challenges, is do you stop because you like it too much and you want something new, or do you stop because you hate it? And you see this middle one, they started, they made it all the way to the finish of the song. You can see it's actually listed as finished. So there's quite a lot of detail in that log file, and that really matters. First of all, you have to decide, is that important for your recommender as you're writing your code? Do you want to wash some of that out and keep it simpler? Do you want to keep it in? Because it's a rich additional indicator of what people actually like and what they're interested in. It turns out in music listening, that's a very useful type of data to have. The next one is the user ID. Remember, we're doing this as watching interactions per individual person, so that really matters. And in this case, there was both artist and track information in the same log file. Taking the example that we just looked at, it so happens that 2461 actually is Duke Ellington, and this is a log file of how it generated that connection for people listening to, as I think it was the A Train. So just a quick review of how, we've already gone through this, but basically how this works. You take those log files, you use those as your user histories for how people, a huge number of people are interacting with items. And we used Apache Mahout. You could do it in other ways. Built the recommender model. The output are these indicators of interesting co-occurrence. We happen to use Apache Solr in the form of LucidWorks for our search technology. We would have already loaded up those same documents with the item metadata. And what's really important here is all of this, which is kind of expensive in terms of computation and time, all of this can be done in advance. This is all being done offline. This is the expensive part, and you take care of it ahead of time. This is just a sample of what the actual documents look like, and you can see those, the bottom line on each one is the field for indicator artist. I think we'll skip through this. Sometimes you can look at LucidWorks, but it has some really nice ways to look inside and see what's going on. This particular example, I happen to know artist 303 is the Beatles. You know, so now you only have to be 50 years old instead of 90 years old. And it was making a recommendation between the Beatles and Chuck Berry. Probably not 10 people in the room who know who these people are unless you have really old taste in music, but it's what we happen to have. And so the end result is that you have happy listeners who stay on the site and come back, subscribe or whatever, because in addition to the choices that they're making, they're being offered other choices of other data that they can keep listening to. This was actually done. I do consulting for an enterprise company that's got a distribution of Apache Hadoop called MapR Technologies, and this was developed for them. We actually developed it on a MapR cluster for Apache Hadoop. This was put in to explain when we were actually teaching people how to do this, because this was actually part of a technical course where we did give people the code. This is actually what the architectural design looks like when you do it on Apache or on MapR as a Hadoop cluster. If you use a different Hadoop distribution, you have to do it slightly differently because MapR has a fully read-write real-time file system. HDFS, other Hadoop systems don't. And so you still can do it, absolutely. You just have maybe an extra step with a Flume cluster coming in. The Python script wouldn't work directly on the distributed file system. You'd have to copy in and out. But the basic recommender works in exactly the same way. Okay, I'm going to skip through the math, but the key thing to look this little bit of, for people who actually want to look at some real math, There really is a choice of doing this kind of recommendation as user-centric or item-centric. What we did was item-centric, and we did it because by doing an item-centric design, you can do that, the computing of things that don't change quickly offline ahead of time. It makes it a very powerful design. You could have done it as a user-centric one. You wouldn't be able to do quite as fast a response in real time when a new user comes in to make the recommendation. I'm just going to mention this, think about it later. What we talked about was a simple system where the behavior that we looked at is directly matched to what we're recommending, a much more powerful, more common system, multimodal recommendation. So people do a variety of different things, and so what you're recommending is based on their behavior, say listening to music, but it also might be based on their behavior, what restaurant they went to, or what book they bought. I'm going to have to skip this because I want to talk to you about the project, but these are two ways that you can actually do really simple techniques that make a recommendation system stronger. And mainly, even if it doesn't make it stronger in the first week or month that it's deployed, it makes it robust over time because it gives the user variety. Dithering is an example. We'll talk about there's time at the end, but these are real numbers. People, anything that they have to even scroll down for, there's a huge drop in the likelihood people interact with it, and you have to go to a second page, there's a real drop. So you really have to think about that in terms of what you recommended. And if you have items that are below the scroller that they have to go to a second page, you may never know what their interest is in those items. It's hard to bring in new material. So you have to have techniques to keep kind of churning the system and bringing in new material. So we have, actually, when is this over? 3:45? Okay, we can come back to that, but let's spend some time actually talking about the Mahout project. And then I would like to give these books away to anybody who would like a copy. It's also available electronically if people don't want to carry a physical copy around. The physical copy of the book is being donated by MapR, but there's a link. I think right now the link is still exclusive to MapR. They purchased the right to hold that link from O'Reilly, and then as soon as MapR releases it, which will probably be in a week or two, then it's available directly from O'Reilly. Apache Mahout project. Let's switch gears. How many people in here actually do machine learning now with Mahout or with anything else? A good number of you. Great. So I'll let you answer all of the questions that come up in the next part of the talk. Secondly, how many people have used Mahout or interacted with the Mahout community? Okay, a few people. And how many people in here are involved in other large community open source projects? Which ones, starting in the back, which ones do you work with?
I guess not more, but a lot of stuff in geotechnical, GIS, Postgres.
Yes. Okay, and there were some hands up here. Yes?
Not related to work,
okay. And there was a yes? Okay. Okay. Well, there's a challenge in doing open source work with the community, and the ones that I'm mainly familiar with are two of the Apache Foundation projects. One is a new project called Apache Drill, which is ramping up for its beta release, and it's a way to do ad hoc interactive analysis and uses full SQL service and to do it at scale. We'll talk more about it later. There won't be time to talk about it now. But the other project, the one that I have the biggest interest in, is the Apache Mahout project. And Apache Mahout is a little bit unusual as a project, is that it's fairly large, it's been very successful, and it, with the exception of one person I can think of, it really is being done by people who basically are volunteering their time. It's not their day job. So it's a ton of work. There is no physical place that is the center of Apache Mahout. There's no single company that has its big shoulder behind it where the center of the universe for that company. And so it's an interesting contrast with the other one I've been working with, which is Apache Drill, which is a fully open source, and open source not just for the code, but open development project, but it's one that's being heavily supported by MapR technologies, and they have a number of full-time engineers that work on it. So you can sort of know that kind of the center of Apache development. For example, they're having a hackathon tomorrow at the MapR headquarters. Apache Mahout is a very different sort of situation. People are scattered around the world, and there is no single place that is Mahout. There's an open source conference, which I think is fantastic. I'll probably go to it this year. This will be my 4th year. It'll be in late May. And it's called Berlin Buzzwords. And it's a purely open source conference, and kind of not officially, but coincidentally, it's kind of becoming the annual place that people who are Mahout committers, and strangely enough, I am a Mahout committer, though I don't write code, people who are Mahout committers can actually come together and see each other, in the flesh more than 1 or 2 people who happen to meet up at a conference. Many of them go to that conference, and it provides a rich environment. As a quick aside, this is the first time I've been at the Philly Emerging Tech Conference, and a lot of what I love about the Berlin Buzzwords Conference, it's so rich, not just in terms of the content, but the interactions between people. It's kind of become its own community in a way, and I get very much the flavor of that here. I know a lot of people have come back a number of times here. Very, very impressed by what happens at this conference. So dealing with community is a non-trivial thing, especially where people are dispersed. One of the things that I did to try to help the Mahout community, since I don't write code, is I started a Twitter entity, and it helps keep people interconnected and having conversations. I'm an organizer for an Apache Mahout meetup group. We just had a meeting last week that was sponsored by Intuit in the Bay Area. If anybody's interested in Mahout and would like to start a meetup where they are, there right now is an enormously increased interest in the Mahout project. And that might be a fun thing for you to do, and that would be terrific, and would be happy to help. You can always contact me if you want some ideas about how to do that. Okay, so what I thought I would be telling you about Mahout is Mahout in the last year has had 2 large releases. Last summer, Mahout.8 was released, and it was a huge cleanup of the project. They deprecated a lot of the algorithms that were okay, but they just weren't ones that people were especially using. Decided to really focus in on the parts that work the best so that could be done in a really rich way. And they added some excellent algorithms, one being a streaming k-means algorithm. I call it a screaming k-means algorithm because it's very, very fast. Some other things were added, connections to Scala. The Apache Mahout library was very much beefed up, and it's a wonderful thing. People are not as aware of it, but it's actually a very good thing for people really doing their own deep development. Not just if you're using a Mahout, you may not even use Mahout, but the Mahout math library is an excellent source and tool to be used. So that was the 0.8 release. That was July. February of this year was the 0.9 release. I think that actually was where Scala came in. There were some more algorithms, some more cleanup, and so forth. I can give you a link to a blog that kind of summarizes it. I'm not going to take time to do that now. And we thought what was going to happen is, over a very short period of time, be ready for the Mahout 1.0 release. And coming from 0.9 in February to 1.0 was just going to be this simple cleanup. The project really wasn't going to change. We already knew what it was at 0.9. And people were going to, clean up bugs, add a little documentation, and Bob's Drunko ready to go. And then people really, well, I started to say they got a bug, but you're all computer programmers. So they didn't get a bug, they got a bright idea. About 8 weeks ago, and decided to completely change the Mahout project. And so suddenly 1.0 is going to look not at all like 0.9. It's a huge amount of work. I'm very much enthusiastic about what's happening, and very much spending time trying to connect people and help support this to happen, even though I basically shot myself in the foot, because the full-length How Do You Do Mahout book, which is called Mahout in Action, was published by Manning in October 2011. We had already started revising it because it needed to come up to match the 0.9 code. And we actually have a new author on it, which is really good. Sean Owen was an author in the original book, and did not want to actively be involved in writing the revision, and has been kind of pulled away from Mahout. And so we added a new author, Sebastian Schelter, who's actually in Berlin. He's a PhD student there and fantastically good at recommendation. Everybody's geared up. We start doing the revision, and then decided to make this change. So what was going to be a revising the book, rewrite a couple of things in clustering and bring it up to date with 0.9 code is now go back and rewrite the entire book because everything's going to change. So I don't know when the new edition of Mahout in Action will be out now. So what's happened? Here's the roadmap to Apache Mahout 1.0. As many of you have heard, been a lot of discussion about this, Mahout made the decision to move away from MapReduce. So they are officially still supporting some algorithms that use MapReduce because there are things that are in production, but they are not accepting any new algorithms, and it's not clear these decisions are being made as they go forward. How long will they do the support for the current algorithms is not decided yet, but they very much want to support the people who are using it in production. There are a number of changes that are happening in 1.0, but the ones that have gotten the most kind of discussion, publicity, and are being executed now, and so we know what's at least intended, and if not, what will happen. The first is the move to support Apache Spark. And that's something that's very, very popular. I have a little bit to tell you about Apache Spark, but instead I recommend, wave your hand back there. This is Dean Wempler, and right after this talk, he's in another room giving a talk about Apache Spark, so I would recommend you go listen to his talk instead of me trying to describe it to you. But the main thing is, by a change to Apache Spark, it should make the project much easier to use, should make it much, much faster, especially in certain settings. Apache Spark is a platform for a wide variety of large-scale processing, but mainly for situations where you can run things in memory, all in memory. It's very, very fast and a very good approach there. So just a little summary of different things. Apache Spark was started by some people who are at Berkeley. They have subsequently formed an enterprise company called Databricks. So it was Spark. They formed the company Databricks. It's now become an Apache project. It just was raised to the level of a top-level Apache project, and it has a lot of support and a huge amount of interest, a lot of user groups springing up and so forth. So there's a lot of activity there. What is probably less known, but also very, very exciting to people who have taken a good look at it, but I see a gentleman back here shaking his head no, so he'll talk to you about why he thinks no, is a different open source project. It's called H2O. These are really poorly chosen names because they're very hard to search because they all mean something else. The company, written like that, is pronounced Hexdata. So very clever name, except very hard for anybody to know how to put the name down. Those names are all about to change. So this is an enterprise company that's in Mountain View, California. They developed this fantastically fast, high performance, really elegant. This gentleman says the code is ugly, and I can't address that because that's not what I can look at. But what I can look at is I've seen it in action. I can see what it can do, and I've talked to people who have deep, deep expertise in the field, and they're hugely excited about this. So the H2O is open source, but was privately developed by Hexdata. Right now, they are actively working to make it connected to the Apache Mahout project. There's still a question about, they were somewhat interested, they might just decide to donate all of the code. It may be that their investors don't want to do that, but want to build a bridge, a binding so that there's the support so you can actually run it with Mahout. So some of the things that Spark does, H2O doesn't do. Some of the things that Spark does, H2O does, and in fact actually does faster, so that's a good thing. And H2O actually brings in some really interesting options for doing very large scale, very effective use of R for people who like R, statistical programming language. And it also has some beautiful algorithms for doing deep learning. So there's a lot of interest in that. Now we'll add a layer to Mahout that hasn't previously been there. So right now there is a subset of people who are also developing the connections to H2O and Hexdata. There's a third movement afoot, and I didn't refer to it here because it's too new to deserve a slide. But there's another project, I think better known in Europe, that's called Stratosphere. And there's another group of people who are beginning to look at the question of whether they want to build connections between Mahout and Stratosphere as well. But right now the focus is on Scala, Spark, and H2O. And just as a way to think about it, the main three areas, there are other things that Mahout does, but the main three areas of use for Mahout are clustering, recommendation, and classification. And now it deserves a block of its own, the Mahout math library, which can also be a standalone piece. And what will basically happen is that now they will be running in a much more uniform way. In not all choices, but in most choices, people will have a choice between running it based on Spark or running it based on H2O, because they are strong and different. Some are easier, some are harder. And so that choice will be there. One of the changes, one of the decisions that's being made, and I think it has pretty much been made, a lot of this is happening while I'm on the plane, is how far to go with the move away from MapReduce. And so that's not fully decided yet. And one of the problems had been that the way Mahout was built is that these different sections, clustering, recommendation, classification, actually came through a different sort of structure for a MapReduce layer. So if you were doing a project where you were trying to go from one to the other, for example, it's not that unusual to start as a preliminary project with clustering and then you follow it up with classification. One of the examples we gave was actually using classification, but using it in a recommendation setting. So sometimes you're trying to run two things together. That had been clunky. It worked with Mahout, but it was quite clunky. Now it's going to be very, very clean, very fast, very easy to interconnect things, and people will have a choice of how they want to do that. When will all this be ready? I don't know. The work on Scala and Spark started earlier, so it's way ahead of the work on H2O. And as I said, this is, with the exception of one committer, it's nobody's day job, but people are working on it. They're so excited about it. And there's just, it's amazing flavor in the project right now. People are just so fired up. And there's been enormous amount of interest around the world in it. So the last piece that I wanted to talk about before I hand you a bunch of books is this is a really good community. We heard a lot in the various talks today about how hard it is to maintain a community, and especially after it gets large. I don't know the full size of this. I haven't looked real recently. I actually helped write the quarterly reports for the Apache Drill project, so I know exactly the size and activity there. I don't do that for Apache Mahout. I do run the little Twitter entity. It's been on Twitter for about a year plus a month or two. It's got about 1,500, 1,600 followers, and that's growing suddenly a lot. So there are a lot of people interested in it. This is an excellent time. If you want to use the project, great. If you use Mahout, be aware that everything that we just described can still be done, but the algorithms are changing, and you'll probably want to keep alert to that. If you use it, and especially as you use the new versions of it that come out, one of the things that you can do that is enormously valuable to the project is let people know. Let people know. Write a blog, contact via Apache Mahout, the Twitter entity, get on the mailing list, the user list, and say, I did this, and this is what happened, and this is what I liked, and this is what I didn't like. It's phenomenally important because the developers are really, really busy trying to develop it, but they need to know what happens when other people try to use it. So that's an enormously helpful way, even if you just try out a piece, is give feedback. It's a tremendous contribution to a project. Other ways, obviously, is most of the people in here are developers, is start writing code, get involved in the project. A lot of times in open source, people say, you're interested, jump in there and subscribe to the user mailing list or the developer mailing list. And I recommend that to all of you. I also know that if you don't want necessarily, you haven't decided to do that, you don't really want an extra 100 emails a day in your inbox, that another thing you might want to do is go onto the Apache Mahout site, and you'll see a place under the mailing list where you can go to the archive. And you can pop open the archive for the developer list or for the user list, and you can just run down per month and year and look at the threads. And without even spending time to open anything and read it, you can just watch where the discussion is going. And from that, you can begin to decide if there's a piece of it you want to know more about or to jump into, just pop in and open up the threads and read it. And so you'll have the advantage of that without it filling up your box. If you find that you're interested in that, please subscribe, join the conversation. This is a really good group of people. They're enthusiastic and they're very welcoming to new people coming in, and would love to see people get involved. If you don't have time to be involved as a developer, that takes quite a bit of time. As I said, try the project, get feedback, especially the new pieces of the project, or it really takes somebody with a lot of technical expertise to write documentation, and a huge amount of new documentation is going to be needed because the project's changing so much. So there's a large number of ways to contribute. In an Apache project, there's a smaller number of people who are actually committers who have voting rights in the project. I don't vote on code because I can't review the code. I have to make my little joke. I'm the rare person who is a committer who can't write code. So somebody said, oh, are you going to start learning to program, blah, blah, blah. I said, oh, wow, boy, I would love to do that in my spare time, but I can't afford to because right now I have a perfect record. I'm the only person at Apache who's never committed a bug. If I ever wrote a line of code, I could be in trouble. So I help the project in other ways in terms of building the community, communication, writing books, writing a number of books, blogs, whatever, and keeping the conversation going. There are a lot of different ways to contribute. With the Apache Drill project, I'm not a committer, I'm a contributor. It's a less official, I have no official status of anything, but most, at least the Apache projects, they're all different, but most of them acknowledge people who make a large level of contributions on the website. It's kind of a nice feeling to know that you've done that. So many, many different ways to get involved in these projects. Would love to see you guys do it. So that's it. I have a few books here. If you'd like, this little book is the content of what we talked about today. This is published by O'Reilly. It's the first in a series called Practical Machine Learning, which I keep seeing people refer to it, or the, quote, e-book book. And so I don't know. I have a contract with O'Reilly to write an actual book about a different topic, and we're just looking at Mahout, and I'll guarantee you that doesn't feel like a book to me, but so these wonderful glossy white papers, I'll call them that. There's a second one in the series, which I was supposed to finish the manuscript for yesterday, but didn't quite finish editing it, so I know what I'll be doing tonight. And that one is called Practical Machine Learning Anomaly Detection. And we're making a decision about the third one in the series now. The anomaly detection one, if there's not too much of a penalty from having missed my deadline yesterday, will probably be available in early June in print. It'll be available probably just not before that as an electronic book. This one is also available electronically if you don't want to lug a book back. So that's it. I guess I have one more slide. Would love to hear from you guys if you have questions, if you want to be involved. Yes, do you want a pony, which is to remind me to give you a book. And this is contact information. And thank you so much for coming.